So listen up. Greetings and welcome. Today we're talking about the history of numbers, humankind, and their belief in numbers, and kind of what historically happened over time. It's going to be great, and maybe even our own belief in numbers. So the first kind of numbers that existed were positive counting numbers, right? Which is probably what you'd guess, right? So, right, because that makes sense, because you could have like a little sheep or something like that, right? And he'd all be like this, right? And he'd be like, meh, right? And there's my sheep, all right? That's my sheep right there. And so, like, if you were a shepherd, you'd be all like, yeah, I've got like one sheep. That makes sense. Or I could have like, you know, let's see, this one's gonna even be sloppily drawn. It's a monster.
It'd be a moose, though.
There we go. And I understand the concept of two sheep, right? So they'd count in whole numbers, all right? Natural numbers is actually the way I should more specifically say it. So that's what people started to believe in, was natural numbers. I can have 7 apples. I can have 100 bottles of, or vases of water, or jars of whatever, or right, grain, or silos, or sheep, right? They understood the idea of counting numbers. And that's where mathematics first started. They probably ended up getting some understanding of addition and subtraction and multiplication and division. Stuff like that probably started coming about at that point. Eventually, they hit the whole numbers. And what's the difference between whole numbers and these are called the natural numbers up here? Does anyone know? Zeros included. The whole numbers include 0. Because like at first they would have been all like, what does like 0 sheep look like, you know? And it would have like been like a sheep that was what, invisible? Like that didn't make any sense. Why would you even count an invisible sheep, right? That doesn't make any sense. So right there's my semi-invisible sheep. So this is 0 sheep. I don't have any sheep. Okay, they would have been like, what's the point of even having a number like 0? It doesn't make any sense. Why would you? That's why, right? That doesn't make any sense. But eventually 0 became a number that was more widely accepted. The next kind of number that would have been believed in were the integers. What do integers include that whole numbers do not? No? Negative numbers. All right, so it includes the negative. And that made no sense. I mean, think of, all right, so you want me to believe in 0 sheep, but now what does -5 sheep look like? Exactly. As Americans, we understand the idea of negative numbers because of debt. We get the idea of negative numbers a lot. In fact, negative numbers, I think the whole minus sign first originated, might have been in some German accounting books that are ancient and discovered. I don't remember. Somewhere in Europe, though, where they found plus for anything that was added into an account and minus for anything that was taken away. So that's kind of where the minus sign came from. And we understand negative numbers, right, because we understand, right, I owe my neighbor a sheep, right, sort of thing. I owe somebody a sheep, right?
Actually, 5 sheep.
Yeah, maybe 5 sheep, right? So it's like, I currently have 0 sheep and my neighbor is all mad at me. He's all like, give me my sheep. Where my sheep at, right, is what he'd be all saying. Let's see, sheep at, there we go. Right, and he's all mad. He's like, you owe me 5 sheep, dude. Man, he's got like a unibrow going there too.
And that's a happy face.
Oh, no, he's not happy though. Oh, I just ripped his eyes out. There we go. Is that better?
Yeah, now it looks mad.
All right. And here, this arm's longer than the other one, and it has a fist that he's shaking on it. There it goes.
His arm's longer than the other one.
Yeah. It's, yeah.
Yeah, his like left side of his body is longer than the right side.
Yeah.
Look at his leg.
Yeah. Also true. Excellent. So he's all like, where's my sheep at? So negative numbers, people are like, okay, I could believe in those. The next numbers to be believed in would have been rational numbers. which include fractions. So why do you think rational numbers would have started to exist?
They were cutting the sheep up.
Okay, if you were butchering sheep, you could own half a sheep, right? Me and my neighbor split a sheep 50-50. I own half of it, half of its wool, half of the meat, half of whatever, right? Right, so rational numbers. It probably related more to like the idea of measurement, maybe. So like if I had like my awesome, here's a jar, I don't know, that's my awesome jar. I don't know. And I could have a full jar of water, right? So it's like all water, right? Or I could have like a half a jar of water or a quarter jar of water, right? Stuff like that. Where, oh man, these jars are getting worse. And there's aha. So like if I was measuring liquid, right? Or if I was measuring like fistfuls of grain or spices, right? Rational number, fractions started to exist, right? Fractions, right? Rational numbers, right? So like a half, right? Stuff like that. And it turns out different parts of the world would have been at different places with numbers. It turns out like the Greeks were huge fans of positive numbers. They had an understanding of zero. They understood rational numbers, but they didn't believe in negative numbers. So there was kind of like some different pockets in the world that would have been at different stages. But they believed in rational numbers, right? And that was because the Greeks perceived the whole world through the eyes of geometry. All right, that's where they looked at mathematics from that window. So the idea of a negative length of a square doesn't make any sense to them. So they didn't have the need for negative numbers. Now, little side story. You guys might know about this dude Pythagoras, right?
Yes.
The Pythagorean theorem.
Which is like a squared.
Right. So here's Pythagoras. He's all like, look at me. I've got this awesome beard. I imagine maybe he had. Look at, there's Pythagoras. Bam. He's just like, awesome. Why don't people have mustaches on top of their noses? That'd be weird. So here's Pythagoras. He would just all be like, yeah, man, I'm loving the math, right? Represent. And it turned out Pythagoras loved fractions, all right? He was all like, yeah, fractions are awesome. And he started his own cult. Yep, that's where this is going.
No.
Where, right, he had a school, essentially, right, of mathematicians that he was training, and they would discover different things. So the Pythagorean theorem, first of all, it has been proven it was known by the Chinese long before Pythagoras. However, they didn't get credit for it, and we don't know who within China would have known the theorem. And in the case of Pythagoras, he maybe wasn't the guy who discovered the Pythagorean theorem either. It might have been one of his students, and then he's just like, hey, that's pretty cool. I'm going to take credit for that, right? And so Pythagoras, known for the Pythagorean theorem, given credit for the Pythagorean theorem, didn't necessarily be, he wasn't the one that necessarily invented it, right, or discovered it, rather. But he did end up having this religion at his school where he believed the whole world could be represented by proportions, all right? He saw beauty in the world's proportions, so like day and night and the ratios of heights and widths and all sorts of things. He believed the whole world could be represented by proportions. So unlike perhaps us, where maybe many of us hate fractions, he hated any number that couldn't be written as a fraction. All right? In fact, he didn't even believe in them. All right? And he believed every number could be written as a fraction of integers, in fact, rational numbers.
Is that where irrational numbers come?
Well, it turns out one of his students, and I never remember this guy's name, so let's have one of his students. He's got like this cool little haircut here. Let's see. He's all like this, and he's like, hey, here I am. I'm a student, and he's like, yeah. Let's see. There now he's got an ear too, and he's all like, yo, Pythagoras, check this out. Here I've got a triangle, right, of leg lengths 1 and 1, and using the theorem that you perhaps discovered, I showed that 1 squared plus 1 squared equals c squared, so 1 plus 1 equals c squared. So c, he ends up showing, is equal to the square root of 2, all right? is what he ends up showing. And so he's all like, yo, check this out, Pythag, square root of 2, what's up? And he ends up also developing his own proof showing that the square root of 2 cannot be written as a fraction. It's in fact irrational. The square root of 2, by the way, is approximately 1.414. It's an infinitely long, non-repeating decimal, so the next number I don't believe is a 1. I'm quite certain anyway. So Pythagoras was kind of all like, dude, you're ruining my religion. I'm like a cult leader here, man. And he's all like, "Urgh." And he's like, "Urgh," right? And he's all upset about this because square root of 2 is like throwing his religion in his face and also using his theorem to do it. He's all just like, what? And kid's like, dude, but it's real. I proved it. Pythagoras, what he ends up doing is he sends this kid out in a boat. He's all like, come on, a boat, dude. And he's like, so the kid's all in the boat. So here's the kid with his funky little haircut, maybe. I don't know actually what the kid's haircut looked like. And the kid's kind of nervous, right? Because, yeah, it almost looks like a hat there. That's pretty good. I'll give him a little cowlick there, right? Bam. And what happens was Pythagoras kind of sent him out, and he ties him up on this boat, or sent maybe some of his math goons to do the hard work, and they throw him into the ocean and kill him.
Okay, why?
So yeah, Pythagoras, our beloved mathematician, sadly was also a cult leader and a murderer. So there you go. Choose your heroes more wisely next time, friends. So there you go. So there's poor little dude. He drowns and dies. Which actually, I always thought, what if irrational numbers were illegal today? What if like our government was founded on the same religion that Pythagoras had, and I told you about the square root of 2, and then like snipers like from like the hills like take me out, like SWAT team swings in through the windows, like flash bangs, and just like, yeah, it would be like super illegal to teach about irrational numbers. I mean,
that'd be pretty crazy.
Yeah, that'd be an interesting society. So eventually, though, mankind chose to believe in irrational numbers. And I guess Pythagoras was really irrational in his behavior and not believing in them, right? So irrational numbers are like the square root of 2, or pi, or e, or the square root of 17, any non-reducible number like that. So eventually the world believed in irrational numbers. Good stuff.
13 divided by 7.
Okay, we won't.
22 divided by 7.
22 divided by 7? Wasn't that one of the early approximations for pi?
Yeah.
Yeah, I forget what culture that one was. But yeah, cultures used to have estimates for pi. Here, guys, we're talking stories right now. Friends? Yeah, go to the nurse if you need to. But anyways, so the next thing mathematicians talked about actually weren't numbers at all, but it was the idea of infinity. It's not a number. No. And mathematicians were all like kind of debating whether or not this idea of infinity or infinitely many of something even existed. And it turned out kind of the two parties that formed. One of them was a group of religious Christian monks, and they were like, well, infinity has to exist because it's the only way we can quantify our God, right? Because they're like, he's, infinitely powerful, infinitely, all-knowing, has lived for infinity. And so that was kind of some of their arguments. And eventually the debate settled where they did believe in it. And it turns out, if you think about it, so our number line is infinitely long, but it's also infinitely small, right? Between 0 and 1, I could find 1/10, and then 1/100th, and 1/1000th, and I could get like super, super tiny where I could kind of like zoom in on this, and I could try to find a number that's really close to 0 and say like, this is the smallest number, so 0.001, and then like I could find a tenth of that, 0.0001, and then a tenth of that, and a tenth of that, right? And I could just keep getting smaller and smaller. So the idea was that, time, for instance, in their minds could be infinitely divided, right? So eventually mathematicians believed in infinity. And what we're going to talk about today, so I don't know, sometimes Students have told me that they don't feel comfortable believing in infinity. Okay, that's fine. That has happened.
I know you feel comfortable.
My wife doesn't like infinitely large numbers. Infinity scares her, and I respect that. I respect that. But the next type of number we're going to talk about are imaginary numbers.
They're not real though.
Well, but you saying that imaginary numbers aren't real is like someone saying back in the day, the sheep farmer, like, negative numbers, those don't exist. Am I right? Negative numbers, what?
Imaginary.
Right. Imagination, exactly. So it turns out imaginary numbers do exist. All right. The name imaginary is perhaps deceptive. The number I is the number that we'll be referring to imaginary numbers, and it's actually equal to the square root of -1, is what they decided I would equal. They were called imaginary numbers by a math bully, yeah, where he was all like, well, I'm just saying that he was all like, oh yeah, those mathematicians and their imaginary numbers, right? And kind of like made fun of them. And then the name stuck, and they're like, yeah, we will call these numbers imaginary. What's up? And like they owned it, right? These are also called non-real numbers. So other non-real numbers would be like the square root of -20, or the fourth root of, say, -100. I don't know, stuff like that. So basically, any even root of a negative is going to end up being imaginary or non-real. And it turns out, even though they have that name, they do exist. Okay, so don't be deceived in that capacity. Don't let your belief limit your understanding of mathematics. And it turns out not only do they exist, but they actually have real-world benefits. In fact, electricians have to use imaginary numbers. They actually, instead of I, for some reason, electricians use the variable j to represent the imaginary number. But in order to calculate kind of I believe it's the impedance of current or different things like that in an electrical circuit, they need imaginary numbers to do that. A real-world problem. All right, engineers use imaginary numbers to, I think they can use it for some statics and bridge truss testing and stuff like that. Imaginary numbers come into play there as well. In fact, let's see, what was I just going to say? Oh, my brain's forgetting it. Oh, I just lost it. Oh, that's right. So you guys are familiar with the quadratic equation, x equals the opposite of b plus or minus the square root of b squared all over 2a, right? You guys know that. It turns out there's also a cubic equation, all right? And the cubic equation requires imaginary numbers to work. Oddly enough, imagine this. I've got a real-world math problem that's super hard to solve. What they'll do is they'll translate it into the imaginary universe. They'll do one simple tweak and take it back into reality, like through some sort of math portal, and they're able to solve it super easily. All right, so kind of interesting stuff. It turns out, in fact, that mathematics, this is kind of like on average in the current era, where a new field or branch of mathematics is discovered, within 7 years, scientists will find out that that branch of mathematics perfectly describes something that they observe in nature, or chemicals, or at the atomic level, or something like that. And then within 7 years of that, engineers find a use for what scientists observed that can be described by that mathematics. And within 7 years of that, a product is on the market that is used by consumers that uses the engineer's design that was observed by scientists, that was discovered by mathematicians and measured accurately. So that's what's up. What's up, Hank?
One example of that.
GPS. The math behind being able to calculate your GPS location was at once thought, a little bit useless and just kind of fun, like I'm just playing with numbers sort of thing. And then it turned out it had to be used in order to calculate GPS location. And now chances are somewhere on your person, if you own a cell phone, you have some sort of GPS tracker on you, and so does most of the planet. Or at least civilized planet, I suppose. So it turns out that's kind of an interesting result. Then also the other thing we'll talk about at some point are complex numbers.
We're supposed to do that today, but
We're hoping. Oh, we'll see. We'll see.
Isn't this getting
Complex numbers are of the form a plus or minus bi, where they have both a real part and an imaginary part. So they're kind of like hybrid. And what's really interesting about complex numbers is they are not contained in their own set when you do operations on them. So for instance, I can multiply some complex numbers and get a real number. Or I can add some complex numbers and get a purely imaginary number. Right? So like when I add two complex numbers, it doesn't necessarily give me another complex. It could actually change which universe that number lives within, which is kind of weird. So I just want to point out that these sorts of numbers do exist. They are real. And just give us a perspective of, even though like we might be like, yeah, but what is I many sheep? That doesn't make any sense. So even though maybe our current capacity or need for numbers may be limited, all right, and we might not see the need for these types of numbers, they do end up having a value to us in society. So that's my little rant about numbers. Bye-bye.